Okay. So first note, what is the so what we understood from this problem? So let me write note here. One second, let me admit everyone. Okay. So what is the note? So from this relation, I understood that so when springs are having equal weight, okay. So that is for equal weight. So when the circular spring and the square springs are having an equal weight, the circular section will absorb 1.62 times as much energy as square section. Understand? So when springs are having an equal weight, obviously the circular section will have more energy absorption than the square section. How much? It will be 1.62 times. Okay. So that is what the final conclusion is. Okay. So let me do the next one. In the same problem, there is another statement which was given as the helical spring, solid circular helical spring of the given diameter is 1.36 times as strong as the square section. Okay, let's prove that. Okay. So right here. So again with the same relations. Again. So let's take for circular section. Circular section. What is torque? Fs into pi d cube by 16, right? So this can be written as Fs into d by 4 times of area, right? Fs into d by 4 times of area. Why? Because area of the circle is pi d square by 4. Okay. So by that, this can be written as Fs into d by 4 into area. So here what we are doing, here we are neglecting stresses due to direct force. Okay. Neglecting stresses due to direct force. What do you mean neglecting stresses due to direct force? So due to direct force, the stresses will be something like, when a member is subjected to direct compression. So there will be direct compression stresses develop. When a member is subjected to direct tension, direct tension, your load will be parallel to the axis of the section. So here we are neglecting that. Okay, so here we are considering only where your circular section is subjected to torsional compression. Okay, so and torsional dwara compress avutunna force matrame we are considering here. That's why your torque will be Fs into pi d cube by 16. Okay, so we are writing this as, and again write the same for square section. For square section. So let me consider it as a T1, T2 for the square section. What is the formula? What is the torque of a square section? 0.208 Fs into B cube. 0.208 Fs into B into area. Right, sir? Why? Because area of the square section is equal to B into B, which is B square. So by that, we can write square section as 0.208 Fs into B into area, right? Clear? So now finally, let's write the comparison or the ratio of the square section to the circular section. Okay. comparison or ratio of two sections. So what is that? T1 by T2 is equal to, what is the value of T1 number? Which is Fs into D by 4 into area, and T2 value is 0.208 Fs into B into area, right? So finally, when you write the ratio of these two, you will get D by 4 into 0.208 times of B, right? Okay. So now tell me, but for equal weights, what will be your pi d square by 4 into L? But for equal weight, what will be equal? Can anyone? When members are having equal weight, what I can make equal? What I can make equal, Amma? So which parameter or which sectional property I can make equal when a member is having an equal weight? Anyone?
Volume.
Very good. We can make volume equal. Okay. So which is pi by 4 d square into L can be equal with volume of what? Square section. Okay. So this is the volume of a circular section, which is volume of a square section. So I can make these two equal. Okay. So by doing this, write down what is D. How can I write D, Amma? D, I'll write you. D is equal to B root of pi by 4. Why? Because your L will get cancelled. Okay. So your D can be written as B root of pi by 4, which will be 1.128 times of B. Right? 1.128 times of B. So substitute your D value in the above equation or an above relation to get the ratio of strength between circular section and a square section. Okay. Substitute your D value here. Try to substitute this. What you will get? So let me write here. T1 by T2 is equal to 1.128 times of B by 4 into 0.208 times of B. Your B will get cancelled and your answer is how much? And the answer 1.128 by 4 into 0.208. How much?
1.35.
1.35 something. You can write it as 1.36. Clear? So now from this, what I understood? From this, I can make a statement like this, which is note 2. For equal weights of circular and square section springs, okay, the circular section is 1.36 times as strong as a square section. So hence we proved. Okay. So which is 1.36 times. Right. So these two statements are very, very important. So here you can write it clearly as circular section is equal to 1.36 times of square section with respect to what? With respect to strength. Circular section is equal to 1.64 times of square section in terms of what? In terms of energy absorbed, or we can also call it as a resilience. Clear? అందరికి అర్థమైందమ్మా ఈ ప్రాబ్లం? 1.64 కదా, సారీ 1.62, సారీ 1.62, not 1.62, రైట్. అందరికి అర్థమైందా ఇది? క్లియర్? ప్లీజ్ గైస్, ఐ వాంట్ రెస్పాన్స్ ఫ్రమ్ యూ. దీనిలో ఏమైనా డౌట్స్ ఉన్నాయా మీకు? Because these two statements are very, very important for all competitive exams. Okay, so because we have derived this relation only based on the formulas, only based on the circular and square section torque equation. Okay, from that only we have derived these two relations. No values were given in the problem. Okay, so by that these two statements are very clearly telling that circular section is 1.36 times of the square section in terms of strength, and in terms of energy absorption, circular section is more strong than the square section. Enta strong ante 1.62 times of the square section in terms of energy, 1.36 times of the square section in terms of strength or in terms of strongness. Okay, so circular section is always better. Clear? Please guys, please respond. Andariki అర్థమైందా? Yes or no? So by that we can start another problem on open coiled helical spring. See, there are 29 participants. If you are responding, it will be good kada. మీరు ఎందుకు అసలు మాట్లాడట్లేదు? ప్లీజ్ గైస్, మీకు అర్థమైందో లేదో చెప్పండి అట్లీస్ట్. హలో హలో గైస్, ఎనీవన్ దేర్? See, if you are not responding, I won't continue the class. Please respond.
Sir,
చెప్పండి.
sir, for equal weight, how the volume is equal, sir?
See, here when the member is having an equal weight, we can take its volume as equal. See, I'm not telling it is going to be practically possible, but for our condition, okay, when the member is having an equal weight, I can consider as its volumes are also equal. Okay, what do you mean volume? Volume ante em cheppandi? So how you calculate the density?
Weight by volume or mass by volume, sir?
Very good. Weight by mass, sorry, weight by volume or mass by volume. So when I'm telling it as an equal weight, can't I take a volume as equal? Yes or no?
Yes, sir.
Right. So with that statement, when the members are having an equal weight, I can consider their densities are equal. Okay, when their densities are equal, I can consider their volumes are also equal. Okay, with that relation, so I took circular section and square sections are having an equal volume. Okay, so with that note, we have derived this problem. Okay.
Okay, sir.
Good. Alla me doubts adite, it will be clear. Fine. Shall we move on to the next problem? Cheppandamma. Okay, note down this. Fourth one. Fourth problem. So because till now we have solved problems on closed coil helical spring. So this is the problem on open coil. We'll do one problem on each method. Okay. Note down this problem. An open coiled helical spring is made up of 15 diameter steel rod. Okay. The coils having 12 complete turns and a mean diameter of 100 Okay. The angle of helix being 12 degrees. This is very, very important. Can anyone tell me what is an angle of helix which differentiate closed coil helical spring and open coil helical spring?
10 degrees, sir.
ఎంత యాంగిల్ క్లోజ్డ్ కి ఓపెన్ కాయిల్డ్ కి డిఫరెన్షియేట్ చేస్తుంది? How much? How much?
10 degrees.
Very good. 10 degrees. So as it is 12 degrees, will it be open coiled or closed coil?
Open coil, sir.
Very good. So that's very clear. Okay. So that's the reason why the angle of helix was given as 12 degrees centigrade. So sorry, 12 degrees, not centigrade. Sorry, 12 degrees. So even though in problem, if they're not mentioning as a open coiled helical spring, just by knowing the angle of helix, you can consider it as a open coiled helical spring. Okay, that is very, very important. In the country, we can't expect every time in the problem they will mention open coiled or closed coil. Okay, with the angle of helix also we can able to decide it. Okay, so calculate the deflection under and axial load of 300 Newton and maximum intensities of direct and shear stresses induced in the section of the wire. If the axial load of 300 Newton is replaced by an axial torque of 8 Newton into meter, calculate the angle of rotation about the axis of the coil and the axial deflection. Okay, so take here N as nothing but modulus of rigidity as 0.84 into 10 power 5 Newton per mm square, and the modulus of elasticity, which is E, as 2.1 into 10 power 5 Newton per mm square. Okay, so this is the problem given. Let me write first the given data. Okay, so from that we will try to solve the problem. Here they are asking you to calculate what? First, they are asking you to calculate the deflection under the axial load. Okay, so and angle of rotation also. Okay, so these two are important parameters. Please try to recollect the formulas which we made for open coiled helical spring. Okay, with those formulas only we are going to solve this problem. Clear? Right. So now I hope you all noted the problem. So now let me start with the given data. Okay. Tell me what is the given data? Problem 4, right? Okay. A open coil helical spring is made up of 15 diameter steel rod, right? And the diameter is 15 and having how many turns? 12 turns, which is nothing but N. And the mean diameter, what is the mean diameter? Capital D is equal to 100 So where your R is equal to 50 Okay. So this is your spring. In this, the wire was given as 15 dia, and the diameter of the coil is given as 100 By that, your radius will be 50 and the number of turns are given as 12. Okay, n as 12. All right. Okay. Next, the angle of helix. What do you mean angle of helix, Amma? 12 degrees. So angle of helix 12 degrees and nothing but alpha. 12 degrees. Calculate the deflection under an axial load of, what is the axial load given? Which is P, 300 Newton, and the maximum intensity of direct shear stress which is induced in the section of the wire. So if the axial load of 300 Newton is replaced by an axial torque, what is the axial torque given? 8 Newton into meter. Okay. So nothing but 8 into 10 cube Newton into mm. Okay. We can also write in this way. Calculate the angle of rotation about the axis of the coil and the axial deflection. So we have to solve it these two. And there are two more parameters given, which is modulus of rigidity as 0.84 into 10 power 5 Newton per mm square. And modulus of elasticity is given as 2.1 into 10 power 5 Newton per mm square. Chandama, any problem, you have to write the given data. Without writing given data, you can't able to substitute this particular values in the formula. Okay, so sometimes you may not get some information to solve the problem. At the time, you can assume the data. Okay, assume చేసుకోవడానికి given data అనేది చాలా important అవుతుంది. Okay, ఏ data ఇచ్చారు, ఏ data ఇవ్వలేదు అనేది you can able to compare just by writing the given data in the problem. Okay, right. Now try to solve the problem. Okay, so let's first formula radham. What is the formula? So here we have to calculate first T and M. Okay, so T is nothing but a torque value and M is nothing but moment. So which we are supposed to calculate with these formulas. T is equal to W or cos alpha. M is equal to W or sin alpha. Okay, please try to remember these two formulas. What is the load given? 300. What is the radius of the coil? 50 cos 12 degrees. 300 into 50 into sin 12 degrees. Tell me what is the torque value and what is the moment value? Chapandamma. What is the torque and moment? Sir, you may ask me, sir, why you are calculating torque and moment for this spring? Why torque and moment both are coming into picture in open coiled helical spring? Can anyone?
Because it undergoes torsion and bending, sir.
Very
as
good,
it is
very
a
good.
open coiled helical spring.
Exactly. As it is open coiled helical spring, open coiled helical spring will tends to rotate and it tends to bend. Okay, in that way. So we are going to calculate torque and moment with this formulas. Values entu cheyamma? The first value is 14672 Newton into mm, and the next one is 3119 Newton into mm. So you can cross check them. Okay, so later on, whenever you find time, please cross check these values with your calculators. And now try to solve the deflection. So what is the deflection formula of a open coil helical spring? Already man cheppan formula entuma 64 W R cube into N secant alpha by D power 4 of cos square alpha by N plus 2 sin square alpha by E. Don't worry, Amma. 100% you get only problems from the springs. Springs ki problems is all important. Okay, so by that you have to remember these formulas to solve the thing. Okay, please try to substitute all the values in this formula. Substitute 64. What is W? 300 into what is R cube? 50 cube 12 secant 12 degrees by 15 power 4 into cos square 12 degrees by 0.84 into 10 power 5 plus 2 into sin square 12 degrees by 2.1 into 10 power 5. Okay, if you solve this, you will get an answer of 6.86 mm. So this is the deflection. Okay, please amma nato paatu parallel ga chestu undandi. Okay, because they're all problems. Anyway, this recorded video will be uploaded in YouTube. You can cross check again also. Mistakes you can just go through again and again. Okay, right. So the deflection which I got with respect to open coil helical spring is 6.86 mm. Okay, right. Now, okay, let me take a new page. Okay, so this is a deflection. So now, after getting the deflection as 6.86 mm, first let me calculate what is the bending stress. Okay, what is the bending stress? Let me calculate the bending stress. In the content, I have calculated the moment, but I need to know what is the bending stress of the open coil helical spring. For that, I have to use the formula of bending stress equation. What is the pure bending equation formula, Amma? Can anyone? M by I is equal to
F by Y.
F by Y. Very good. Then M into Y is equal to F into I. Take your F out. Sorry. Yeah. So how can you write this? Sorry. F into I is equal to M into Y. F is equal to M into Y by I. Okay. So what is I by Y? Which is Z. What did you mean Z, Amma?
Section
Section
modulus.
modulus. So M Rachidi, M into, sorry, M by Z. Okay. So because it is a reversal of this Kabati. Okay. So what is Z? Z is nothing but section modulus. Section modulus of the section. Okay. So finally, your FB can be written as and FB and a bending anamata. Okay, bending stress. M by Z. What is M? 3119 by what is section modulus? Can you tell me what is section modulus of a circular section? Even open coil helical spring is also a circular section. What is section modulus of a circular section? Z is equal to I by Y. What is moment of inertia of a circular section? Pi d power 4 by 64. What is Ym? D by 2. Okay. Solve this. What you will get? Pi d cube by 32. Isn't it? So write on the same here. Pi by 32 into what is the D? D value enter 15. Okay. Solve this. What is your bending stress? 9.41 Newton per mm square. Antena? Clear? So this is the bending stress formula. Bending stress from pure bending equation, M by I is equal to sigma by Y. Okay. So how you calculate the section modulus? Section modulus of the circular section was calculated like this. Okay. So now, after getting your bending stress value, calculate what is the shear stress also. Fs is equal to, okay, with respect to torsion. With respect to torsion, what is the shear stress? T by what? What you will get here?
Pi by 16 d cube.
Very good. Pi by 16 d cube. Yellow chinna formula. Can anyone?
Torsion formula for circular section.
Very good. Pure torsion formula. T by J is equal to G theta by L is equal to Okay, from this relation, T by J is equal to G theta by L. From this relation, you can write this, okay, thing. So what is the torque? The value which we got, 14672 by 5 by 16 into, what is D? 15 cube. 221.1 Newton per meter square. Okay, so this is your bending stress and this is your shear stress. You have calculated bending stress based on the torque equation. You have calculated the shear stress based on the torque equation and bending stress based on the moment equation. Okay, right. So by considering these two, so here we are going to calculate what is that final deflection, what is the terms and all. So in the problem they ask you to calculate the deflection. Deflection are already calculated, which is 6.86 mm. Okay, now so let us see what is the angle of rotation about the axis. Okay, so here let me take new page. So there is a note here which is neglecting the term d tan alpha by 4r. Okay, so here by neglecting this term, so we can write anyway d tan alpha by 4r is equal to 15 tan 12 degrees by 4 into 50, so which is 0.0159 radians. Okay, so from this you can able to calculate the shear stress with respect to this value. Okay, so the final shear stress with respect to the torque is equal to 22.1 times of 1 plus, which is the shear stress value 0.0159. Okay, so finally the shear stress will be 22.5 Newton per mm square. Okay, so why you have calculated this? Why you have calculated the shear stress, which is in terms of the angle of twist? Because as it is having a open coil helical spring, okay, so the effect of d tan alpha by 4r will be some percentage. Okay, so as the problem it was clearly mentioned, see, if the axial load of 300 Newton is replaced by an axial torque of 8 Newton into meter, okay, then the angle of rotation about the axis will be different. Okay, so this is an extra shear stress, which is going to be happen with respect to angle of rotation, sorry, with respect to helix angle. Okay, so where you have to use this term as d tan alpha by 4r. Okay, so where the shear stress will be finally 22.5 Newton per mm square. So the effect of d tan alpha by 4r is going to be how much percentage? ఎంత percentage ఉంటుందమ్మా? The effect of d tan alpha by 4r is how much percentage of the 22.1 Newton per mm square? How much it will be? ఈ 22.1 లో ఈ 22.5 ఎంత percentage? ఎంత ఇది? Which is 1.6 percentage. So where it is very near, that's why we have to neglect this d tan alpha by 4r in the shear stress value. Okay, antena? So let me correct it. 22.1 divided by 22.5 into 100. So which is 98.2, sorry, which is 98.2. Sorry, 22.5 kada. 22.5 divided by 22.1 into 100. Okay, so what is this percentage? 98.2%, sorry, 98.2. So which is minus 100%, it will be 1.8%. Okay, so the relation, I mean, the difference of these two shear stresses will be 1.8%. Okay, by considering the helix angle of 12 degrees centigrade, sorry, 12 degrees. Okay, so this is how we can able to compare. And finally, if you see the deflection formula of your